Welcome to this third episode of our short series about Mathematica and Unity, which is interesting because we can use Unity as a stage with active subjects and elements playing your architecture, and you're able to control this with Mathematica with your code. So our principal idea is that you should model your architecture by code with the lambda calculus within Mathematica, and here you have, different from Blender, you have the ability to have photorealistic output. Here you get active and interactive output of things, vivid, with all the media available. So this is how it works. It's not this important that you're doing it. You simply have to get the idea what all this is about and how these things are connected, how these things are developed, and how you should think about it. So, so maybe when you're interested to learn these things and train it. Nevertheless, it should not be too big a problem to just to follow this tutorial and make your own steps to get a better feeling of what I'm doing. So, all these things need the UnityLink package, which is distributed with Mathematica 12.0. You also have to install and download the MTP editor 1.12 to run all this environment like usual. So this is the UnityLink. Next step is you open a project. Let's call it P01. So this starts Unity. As you know from the previous tutorials, Unity is very heavy, with several gigabytes, and this simply needs time. Okay, here we are. So, as discussed in the earlier tutorials, what we have extra is this Wolfram assets, but we don't touch them on this side. So, what we have here is now access to Unity. So there's a bunch of different commands. You can ask for them with question, and then you say, for example, what is there, with which kind of commands are there, Unity. So So it's a joker, unity in the name, joker at the end, and then you get an idea. These are all the commands available with Unity. So it's quite complete. So I need that. So let's make it like you should do it with my tutorials always. So go and copy this. So this says create a unit as sphere. The name is a sphere. It's a position x, y, and z. Y is always vertical in Unity and a diameter of 0.5. And I call it U object 01. So if you do that, you get a Unity object. And if you go here, you have a sphere. If you select that, this is a sphere, it's called like this, and you see these are our coordinates as we had it. So, take another one. It's a plane. And you don't get an update here, just have to click and then you have the plane. Very simple. So this is how to create objects. And there's a lot of objects. It's like here. You can have cubes, spheres, cylinders, and on all these things. You can create all these things with in this way, as we've seen now with a sphere and with a plane. So if you want to see how this works, go here as in the usual way. Go here and say get help, and then not this one. Get this. And here you see Unity help. It's not that extensive, but you see some explanation how it works. And then you can also see other things and so on, like the usual way. So now we want to see the components here, the components of the sphere. So these are the components, and we can access them with Mathematica. So we say find component sphere, all, and all. Then we see the 4 components we find on the inspector on the left side. If we say we want just the transform, then we get here the transform component. So next step is how to get the properties of the transform component. We can, for example, say it's a sphere again, but you'll make it. You are safe if you say find Unity sphere, but you can say directly sphere because it's not. These names are not unique. You can have them. Good, and this should work. So now we get all the properties of these this transform component. And the properties are, you get here, this is a transform, and these are all the properties. X, Y, Z, rotation, and so on, and there's even more. Local position, Euler angle, local Euler right, up, forward, and so on. You can name, height, flag, and so on. So, now you can say, give me the position here of this object, position, and you get 0.51, which is this position. So you can set a property. You can say sphere, find game object with the name sphere. This is robust. Give the position and put it to 0 point. If you now go here, it's moving because now position is different. Very straightforward, and you see how to access whatever component, whatever property you want to change. So now we want to go with the assets here and create directories for scenes, prefabs, materials, textures, and meshes, as we did it in the previous tutorials. Here you see they are done. Create a texture. So we simply take an image, then we say create Unity texture 2D, and here we always have to say file textures, that's here, and then the name. And we simply say Gaussian, for example, the Gaussian texture, and if you want to make it different, you can do it like this, and then there's a texture. This means string join, and then this is separated from the directory. Make that a file, and by that you can go into the hierarchy of your assets. But you again can try to find game objects and by their name, Gaussian, and so on. Make that, create it, name it the textile, and you see it's created here, and we have a symbolic name for it. Unity texture 01. Now create a material, next step, and you see it's just the same way how to edit and manipulate these things, but you keep track of, and you're able to make loops and start to symbolize these things, which means it's not a production line of things, but you're circulating the things and making it more creative. So, the same with materials. Create a material, material red. If the material folder is not there, it's created in an RGB color 101, and it's here. And we get a material object, and it should be here in meshes. There's a red one, yes. Then materials Gaussian. It's a Gaussian in materials, and with this texture, which means now I get a textured material. So now this has to be assigned. Material, shared material to material. Object 1 is here. Object 1 is a sphere, object 2 is a plane, object 1 gets material 1, which is red, object 2 is a plane, gets material 2, which is the Gaussian texture. If we do that, go here, there. So, yeah, very straightforward. Make it a rigid body, and make the object 1, so the sphere, a sphere collider. So which adds to the thing, rigid body, and the spheres collider. And then you can go to the parameters as we did it with the translation transformation. So we go and manipulate it as you like. So play the scene. It simply says Unity play, and then it's a push of this button here. Yeah, as you would expect if you'd seen the previous movies. So now, what is interesting? Oh, keep it playing. Let it play. So now it's playing, and I can access now these objects being active. So I can ask, find Unity game object with the name sphere. So, and I call it, this is the runtime object 01 and this is game object. And I can ask, as I did it before, for the position. And he's currently on 05050 because it's falling down. I, for example, can drag it. No, this is a, no, this was not good. So now the sphere, I can drag the sphere. So, and now with Mathematica, I have to re-evaluate this because there's another run and the indexes are refreshed. Get the position. Now it's somewhere else. So what I can do is I can say set property object position at 10505. So I can put it here. Or I can say I want to have it on 3. No, in 3 here. Yeah, that's good. And I can put it to a button. So say button of we say click. And then we say property. So now I have a click. Or can I make it more? I can say we had to say the get position of this thing. So I say get position plus, and you should move in 0.5 and 0. That means if I say click, it's moving. Good. Next thing, just play it again. Now we evaluate the indexes, get the position. This is not needed. This is now a row of 2 button. Instead of the string here, I put an icon. The same thing, appearance frame. I don't want this frame. Another one, put it in a row, just with plus 0.1 in x, minus 0.1 in x, just to give you an idea of how this works. And here we are. Okay. Now, put things as a prefit. This is a little more complicated. It needs more steps. So we create a cube, as we did it before. We call it a temporary object. Name cube, x, y, z, size of 1. It's here. So we scale it. It's called local scale. This is a little disturbing because here it's only scale, but it's local scale. 0.1, 4, 2. Make it new line, evaluate, and we see this is now a piece of wall. Position, it's scaled. So if you go here, you see it's underground. This is of 0. And this is underground. So we need to move it up. half of the size here. Good. And rigid body, create box collider as we did it with the sphere. So now it's a physical object staying there. To prefab it, we simply say, again a symbolic name, Unity Prefab 01 should be located in prefabs, this here, cube, and I want to put the temporary object with all its components and parameters in there, and I delete the object on my scene. So if I do this, here we are in prefabs, there is this cube. I can put it here to instantiate it. So create a parent directory. So now we go to this directory here. We simply say create Unity object wall, and here we are and have a wall. Instantiate a prefab, create a Unity game object, we call it cube1. It's of kind prefab 1, which is our wall here. The property is position 5 to 1, and parent is uparent1, which is this object here. I put this, I move it in, it's here. Now it's 5 to 1, and it's of the type cube1. Name cube1, and should be, yeah, good. Take on the second one, put it in the same folder. Now we have 2 of these objects in here. Very simple. Play again. Go here. Play. Okay. And get this link. Now the button should work. To kick the thing. Okay. That's it. This is how it works. Very simple, and I hope you got the idea that you do your programming here, whatever you like, and you see it running there, and you can have an interactive scenario. Thanks for watching. See you.